Hi folks, and we're back. We're back here in GOPR0630 in the physics lab. We're actually going to do the next experiment, if you will, the next activity, Module 2B. And again, as I mentioned before, last time we were here, we've been using this rail, and we've been using this cart, and we've been using this force sensor, and we've been using this string with a mass on the end of it, and we've been using this super pulley and the force sensor into the box and the position sensor. We keep on using this same setup, and we're going to take a very, very similar measurement to what we took last time in Module 2A. But instead of just concentrating on position and velocity and acceleration and time and force and work, now we're going to add our new concept of, well, what work is that thing that actually changes the energy of whatever is being worked on. So if someone does work on something, then we pump it up with energy. And if that thing does work or loses work or it works out, then it loses energy. So then specifically the type of energy that we're going to look at today is the energy of motion, the energy of things having velocity. Things that don't have velocity, at least from our perspective. If I go ahead and put this thing back here on the ground again and this doesn't move, and I go ahead and take my stopwatch and say t equals 0, and now t equals 5 seconds later, and it hasn't moved, that's how we can determine that at the moment in this reference frame, maybe we're all moving because the Earth is spinning, but according to our reference frame here in GOPR0630, this is not moving at the moment. We're not talking about it accelerating, we're just talking about it moving, and it's not. So it has zero velocity, and with zero velocity, even though this has mass, it has zero kinetic energy. Okay, so what we want to do is we want to measure how much work we're going to do when we pull this thing back, sort of like we did last time. We're going to set this thing up again with the starting line. We're going to start down here. Last time I used this, it was down around here at 95. It's going to start, I don't have any weight on there right now, but it's going to start at 100 again. We're going to do the same thing. It is literally the same experiment we did last time, but now we're going to ask the computer, by configuring it properly, to give us different information depending on our model of work is a change in energy, rather than just work is calculated by force times a change in position. So it's kind of cool. I think it's kind of cool that we can describe the same thing. Again, maybe it's boring, we'll describe something else. You can use it to describe whatever you want, but because we are describing the same thing but now using different vocabulary, we now have a giant increase in just that. Our dictionary, our vocabulary of words that we can use to describe all kinds of things that happen. So here we go. Let's see. The force sensor will be used to measure the force applied to the cart. Got it. That's what we did last time. The motion sensor will be used to measure the motion of the cart as it is pulled by a weight of the hanging mass. Yep, same as last time. Data Studio will be used to analyze data. Fantastic. Equations used. The total work will equal the net force times delta x. We did that last time. And oh, by the way, the total work will change the object's speed in one dimension, or its velocity in the x-axis. And what we can do is we can calculate the change in kinetic energy by calculating the kinetic energy when it's done, which is V2, and minus the kinetic energy when it started. So where you are now minus where you were before. So it turns out this is even more evident. We're going to measure our experiment. Again, it's going to start at 95 or so, and it's going to be moving when we start. So it's going to have an initial velocity that's not 0. And before it crashes down here at 180, it's going to be moving before it crashes. So we're actually comparing the velocities of a low velocity or an initial velocity to a high velocity or a higher velocity when it's finished, and then we're going to compare where you are now minus where you were before, and that will be the amount of energy that has been pumped into this little tiny device over here, the cart with the force sensor on top of it, which is kind of cool. Fabulous. Okay, so I'm going to get this guy out of the way so we can do it. Here's our procedure again. It looks very much like we did last time. Attach the motion sensor to the 0 meters. Did that. Attach the super pulley. Got it. Mount the force sensor. Already been done. Place the collision force sensor combination on the track with the sensor hook facing the pulley. You got it. Attach a length of twine. You bet. Drape the twine over the pulley. Fantastic. Plug the leads in. Already did that. Okay. Double click the studio icon. Here we go. And load her up again. So here we go. Double studio. In we go. Fantastic. Again with the close the setup button. Okay. We're going to do our own and make sure that we are connected to the interface 500 and say okay. Looking and ready to use, and we're in. Great. Again, if we were in the lab, this is something we would do all the time, so it gets pretty mundane once we learn how to do it pretty quickly. Let's see here. Add a sensor. We want to add the force sensor. Again, we did this before, so I go to add a sensor. I want to add the force sensor, not the force sensor student version. There's two different versions. Say okay. Great. And then add sensor from the digital sensors, add your motion sensor, same as last time. Add a sensor, change this to digital, go to digital, add a motion sensor and say okay. Great. We have a motion sensor and we have a force sensor. The motion sensor will not be used in this default field. We did the same last time. It looks like it's the same lab, but it is the same similar experiment, but we're interpreting the data differently. Click on the icon of the motion sensor tab. We did that. Click on the motion sensor tab itself. We did that. It should be doing the click, click, click. It does. We need to set this back to 1 meter. We've done that before. Bring this guy back down to 1 meter, which is this guy. And while it's sitting at 1 meter, press the exact equal button. There we go. Excellent. Make sure it can see this all the way down here. So that's down around 2 meters. It moved back again. See where it stops. It stops at around 196 centimeters. Let's see what we got here. We have 195. So yeah, it's about right. Again, it's not exact, but it's close enough for what we need. Change the sample rate on the motion sensor to 50. This time it's 50 hertz. Okay, so it was 10 before. We used 20 last week. Now we're going to go to 50. Wow, really, really fast. Fabulous. Click on the force sensor, okay? Now I'm gonna change this guy and change it to 50 hertz, okay? We're really gonna measure this, okay? There's 50 hertz. It's gonna measure 50 times per second. That's a lot of data. All right, now that you've calibrated the configured motion sensor and the force sensor, the sensor will be configured to automatically start and stop. Great, with the force sensor connected to the mass hanger, move the collision cart as close as it will. I think we did this before. I don't think it will change much. Well, let's try this again. I think we got down here to 95. Let's double check. Yeah, 95 is where that guy is. So I'm going to go ahead and do this again. I'm using the same equipment as we did last time. So I'm starting to move a little bit. 0.95, add 5. That's 1.00. Carefully move it until it just reaches. Great, we're going to do that. It's down here, just reaches the floor, which is there. And we found out that that guy was 185, I think, last time. Again, just barely reaches it. 185, 1.85, subtract 5, 1.80. So the same thing we had last time. All right, go ahead. Oh, we got to tell it to configure it this way. So under sampling options, go to delayed start. Tell it a data measurement, not the force, it's the position, is above 1.0 meters. Go to automatic stop. A data measurement, not force, its position, and is above 1.8. Okay. Start above, and say okay, and double check this. Sampling options. It's going to start when it reaches 1 meter, and it's going to stop when it reaches 1.8. Again with the 0.8. Fabulous. Excellent. We did that, we did that, we did that, we did that, we did that. Okay, now the experiment has been set up. You can configure the data to be displayed will be set up using appropriate graphs. Double click on the graph icon. We did this before as well. Double click on graph. There we go. Make sure force is selected, and that's true. Go ahead and say okay. I can close this guy out over here. Maximize this guy. Again, force versus time. Pull this guy over. Hover the cursor over the, and oh, you know what? It looks like I fixed this in this lab. This is a repeat of what I did last year. Just like remember last week we found an error. We have to do it this way. So hover over the time axis until it turns into a stack of boxes. That's that guy. Click it and then change to position. So that's how we're going to do it rather than clicking and dragging. Looks like this latest version of the software doesn't allow you to click and drag. We had that problem last time we did this. Create a second graph by clicking and dragging the velocity. Okay, again with the velocity. So down we go to the velocity. Excellent. And again, change that up. Is that true? Great. Change it to position again. So on time, go to position. So now we have force versus position and velocity versus position. Okay, cool. In the automatic scaling section, again, click on the tab, double click on the white space of the force versus position. We did this last time as well. Go to the axis settings and adjust axis to fit data. Turn that off and say okay. All right. Move the collision cart towards the pulley so that mass hanger is resting on the floor and press the tear button. Okay. Resting on the floor. I'm even going to go ahead and undo the string thing here. Again, the tear button is over here. I'm going to go ahead and, if I'm quiet, I can hear the clicking. Okay, that's all teared. And I won't tear that again. Excellent. Okay, fantastic. Place a 20-gram mass on the mass hanger. And great. So this time around, we're going to use 20. As a first one, it sounds exactly what we did before. Here's 20. Put it on this little puppy there and bring this guy down. Down we go. All right. All right. Fabulous. Again, have one of your lab partners place their hand in front of the bumper so it doesn't crash. I like that. Pull this back to the starting point. Let's do that gently. Gently, 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 gently. Back to the beginning. Again, try to make it not swinging in the wind like crazy, which is that guy. We're going to start this guy at 95. Awesome. I have some things running around here data-wise. All right. I will do the lab partner thing. And run 1. Press the start button on the Duty Studios interface and release the cart. You do not need to press the stop button. Okay, let's do that. So what I'm going to do, again, I did this last time. I'm going to move my mouse over here. I'm going to put my left finger at 95, and I'm going to put my other finger down here to stop it from crashing once it gets down there. So I'm going to click start, and then I'm going to hold on to it. It's not going anywhere. Notice it's going really, really fast, 50 times per second. Zzz, it sounds like a buzz. As soon as I let this go, it's going to start moving, and then as it gets to 100, it'll start recording. I'm going to put my finger down here. I think I'm going to try to look at the data and see if that works. Here we go. Cool. It seemed to have worked well, okay? We collected force data, which was, again, a pool, it's negative. And again, with the velocity data, it's not perfectly flat because we have some sort of imperfections with the track, but it seems to be heading in that direction. We'll get some data off of it. Examine the data displayed in both graphs, zoom in on the velocity, and make sure you collected smooth data. So I'm going to go do that right quick here. I'm going to go to click on zoom area here, and yeah, it's pretty smooth. Obviously, it has a little bit of some wiggle to it. There's a little bit of nastiness going on here. I suspect that's where, even though I caught it, it sort of moved. I suspect that's where this umbilical cord here was unfolding. Again, we're not using the Bluetooth version of this sensor. We could upgrade all of our sensors, but we get the same data. It's just going to fit this anyway, so it's fine. If the data is very erratic, you will need to delete the run and try again. That's fine. Once you have collected smooth data, place a 500-gram bar on top of the force sensor, move it back to the and start and then try again. Okay, so now we're only doing 2 runs this time around. I'm going to go ahead and bring this guy back. It still is 20 grams on the end of that. We're not going to change how hard we're pulling it. The force should be very similar. Okay, but what we're going to change is we're going to change the total mass of this stack. I'm going to grab a 0.5 kilogram bar, place it kind of nicely in there because I don't want to hurt it. First of all, I'm going to see if it moves. Okay, it does move. That's fine. Okay, it is going to accelerate that little tiny weight on the end there. And I'm going to do the same experiment, but now we're going to get data run number 2. So again, with my mouse, I'm going to collect this at 95, move my mouse over here. When I press start, nothing much will happen, okay, because it hasn't reached the starting line yet. And then I'm going to go ahead and put my fingers down here to catch it so that it doesn't go ahead and crash. But when I do that, first I'm going to hit start, and then I'm going to catch it. So I'll look at the data again. It's not very exciting. It just crashes in my fingers. Here we go. Let's give this a shot. Cool. There we go. Excellent. All right, let's see what we got. Data collection is now complete. Hey, that was a real quick lab. I like that. The next steps will permit you to analyze the data. So it may be, hopefully you're realizing this, if I take a look at this, there's not too terribly much in calculations-wise, a little bit more, but the experiment got quote-unquote easier, but now our data analysis is taking a little bit longer. Not crazy long, but now we're analyzing more things. So what we're doing is we're rather than saying, hey, here's this really, really crazy setup, it's the first time we've done it, go ahead and do this, and then once you're done, just tell me the answer, we're finished. Now we're doing this setup, which looks the same as we did before, and then we look at the data, and it takes a little bit longer to analyze it. Okay, so we have, looking at our data, we have 2 runs. If I go ahead and maximize these guys, we'll notice that I have 2 runs. Wonderful. Run 1 is this magenta thing here, or this, yeah, I guess that's maroon. The maroon value, that's run 1. And again, with the velocity around 1.5. So something special about 1.5. Let's check it out. If I go ahead and move this thing back, which I did, okay, and then I go start here, as this thing is moving, here is my cable. What's happening special around 1.5? Goes here, okay. I don't know. It doesn't. Oh, you know what? Right here is what happened at 1.5. This little tiny cable right there sort of unfurled. Notice there's sort of a pigtail there, and down here around 1.5, it sort of catches and then slides. So it really is a different sort of regime at 1.5. That's how I'm going to explain away this bump. It's not a very special physics bump where something, changed its velocity terribly. It really is. Looks like we have some sort of interference, force-wise, with that cable